Hi everybody and welcome back to AI in the Woods. So if you remember, last time we were talking about the dimensionality of conceptual spaces. And we were also talking about perspective. So depending on which space I find myself in conceptually, I will see things differently. Today we want to talk more about spaces, more about dimensions, but from the point of view of AI systems. And we want to ask, what is it that they learn and how do they learn inside a space? So let me take you back first to our physical space here. And let me talk to you about inference. Inference is a very important concept in the study of meaning, in semantics. And it refers to our ability to predict things from the natural language sentences that we hear. But you could also think about it about the ability to predict, generally speaking. So look at what happens when I move across this frame. I'm going to move left and right, to the right and to the left. And you are making a prediction when I move. And that prediction is that when I move in this direction, my whole body is going to move. So you assume that kind of, the distance between my head and my feet is going to remain the same. And my head is not going to stay here while the rest of my body is moving in that direction. So you've kind of learned that the way that humans walk makes them walk in a particular way that, for instance, usually roughly conserves the distance between the top of their head and their feet. Now, that's something that's specific to humans. If I were an octopus, for instance, and I was making that beautiful movement to propel myself through water, things would be a bit more complex, right? Because every time I would be moving, my tentacles would also be moving towards my body and away from my body. And there might be some regularity in this movement as well. But for instance, it might be a bit harder to predict the distance between the end of my tentacles and my head. But what you can see here is that by observing an object moving in space, you, after a while, you're going to be able to make predictions about the how the different points of that object move together or move away from each other, and so on and so on. So you're making predictions in space. You can do exactly the same thing for concepts. So remember, concepts live in space, so they're going to be at different distances from one another. So maybe I'm in a space at the moment where cat and dog are here, and kind of humans are there, octopuses are maybe a bit further away, and there I've got trees, and further away I have home appliances. So I have points in space that describe concepts, and they have distances between them, and they might move more or less depending on how their meaning evolves. I can learn the relation between two concepts by looking at regularities in language in the world. So one example that one thing that I might learn in this forest, for instance, is I'm actually standing here next to a small blackberry bush. In the summer, it's going to get enormous. It will have flowers at some point, and it will have berries towards the end of the summer. How do I know whether this particular blackberry bush right now might have fruit or not? Well, I have learned relations between the state of the blackberry bushes in this forest and the weather around me. So, for instance, I might relate the fact that the raspberry bush has flowers or fruit to the temperature out there. Spring, mild temperatures, summer, hotter temperatures, and I know that the fruit is going to come when it's really hot. I might also relate the state of the blackberry bush to the amount of sun that I see every day. It doesn't really matter what I pick, but the point is that I have gathered that there is a correspondence, a correlation between those two things. Now imagine the blackberry bush as being one of those points in my conceptual space. And it's moving over time because depending on the season, its value across the property having flowers or having fruit is going to change. In winter, my little blackberry bush here has a value of 0 on having flowers and having fruits. In August, that blackberry bush, which will have grown much larger by then, will have a much higher value on the dimension having fruit. So this makes the point of the blackberry bush move across time, right? It goes through spring and summer, it's going to go towards having fruit and then back again to not having fruit. And the movement of that concept is dependent on the movement of another concept, which is how many hours of sun do I have every day at the moment? Is it a very sunny day? Is it not so sunny day? Is it a cold day? Is it a hot day? So those two things are in relation. And whenever temperature increases on my temperature dimension, then the likelihood of that blackberry bush to have fruit is also going to increase. So what am I doing when I'm learning, as a child that blackberry bushes have fruit in the summer? I am learning this relation, and season after season, I see how the blackberry bush evolves in response to the changes in the climate. So the nice thing is that, as you've seen, we can express this in terms of point in space and their respective position in space, as we were predicting the position of my feet with respect to the position of my head when I moved. And that's exactly what AI systems do. So they're going to learn this kind of regularities, and they're learning them by observing positions of concepts in space. So we've now learned how to do inference with respect to two relevant properties. In this case, I have one property, which is the one I want to predict, which is my blackberry bush having or not having fruit. And I've got potentially two other properties, temperature and the amount of sun I get every day. So actually, this is a space in 3 dimensions, right? And in that space, I can observe the relation between properties. If you think about it, probably 2 of those properties are redundant, right? So when temperatures rise, I also know that on average, I'm going to get more sun every day. So maybe those are redundant. Maybe I don't need them. Maybe I don't need a 3-dimensional space. I need just a 2-dimensional space. And which property I pick, whether I pick sun or temperature, maybe doesn't matter so much. So we've got 2 different 2-dimensional spaces that might allow me to make inferences about whether I can go out and get blackberries or not in this forest. This process of selecting features that might be important to a prediction is called feature selection in machine learning systems. And it's a process whereby you try to pick those properties that are relevant to your problem and you ignore everything else. And ideally, you want to end up with the smallest possible space, so the space with as few dimensions as possible, because you don't want necessarily redundancy, and you don't want to be lumbered with lots of irrelevant features, like my mood today. My mood doesn't impact whether the blackberry bush will have fruit or not. So you see that what your machine learning system is going to do is kind of pop out a space in the course of learning, which is the space with the right features. And in that space, it's going to learn relations between properties in order to describe and predict things that are of importance for a particular task. So that's about prediction and thinking in space and learning in space. You're probably wondering, how does this learning happen? So how do I learn the correlation between two properties? We'll talk about that in the next video. We'll talk about functions, and we'll describe what a function is and what it does for our AI systems. So see you there, and enjoy the snow today.